Hey everybody, welcome back. Today we're going to be building upon our database management video, which was 2 videos ago. We're going to be combining with a little bit of web scraping to give you more of a real life example of how we can use this to make things a little bit easier for us for data management purposes. We're going to be scraping a single table from NBA.com, and we're going to be automatically inserting that into a database, and then we're going to double check our database and make sure everything's all there. And pretty simple stuff, shouldn't take too long, so let's go ahead and hop in. So first thing we're going to do, most of this we're going to go pretty quick because we already have several videos out on web scraping where we go over all of this. So basically we are just importing all of our statements, we're defining some options for our web driver, and then we're going to establish the web driver, and we're going to go ahead and bring that up here so we can see side by side. So what we've done here is just, create a Google Chrome web instance that's going to be controlled automatically with our Python code. So we're going to pass the URL for the traditional stats page, and we're going to tell our WebDriver to go get it, and that's going to pull up our stats here. Now if you recall, the next thing we need to do is we need to interact with this little select button here where it says page 1 of 10. We need to switch that to all so we can get all of the data on one table. You will run into instances with rather large tables, think like box scores, where you're going to have an instance for every player for every game. That adds up very quickly. I've had instances where the table itself, the page is too big, I can't pass it through, so then you do have to kind of loop over every page, pull it out and append it into a data frame, but for this one we don't have to worry about that. So we're going to look at that element by XPath. We're going to tell our driver where to go, we're going to tell it to click on it, we're going to tell it to click the 0th option, which is the first option, which is going to be all, it's at the top of the list. If all of this is like a foreign language to you, go check out the web scraping videos, we go over this in much more detail there and explain it pretty well. Then we're going to take the HTML response and look at the source, and we're going to convert that to a soup object. Apologies if you can hear my cat screaming. So now that we have our soup object, we can start parsing over it. We're looking for a table, and again, check out the web scraping video if none of this is clicking for you. Now that we have our soup object, which is just a unique object, basically taking the source code for the page, and we're going to look for our table. We already know what we're looking for because we've done this before, and again, please go check out the previous web scraping videos if this doesn't make sense to you. But we're pulling out the headers, we're stripping down the excess, we're getting it in text, we're dropping out the ranks because that changes based on how you sort and we don't really need that. Then we're going to find all the rows within the table, pull out the stats, blah 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 blah. And then one thing we're going to do that we've not done before is pull out the player IDs here. And this is kind of building on what we went over in our previous video with the data dictionary. We're going to start laying the groundwork to build something like that out. And we don't want to rely on the player name strings. While it's very unlikely that NBA is going to have a typo and push out a bad player name to a table, or basketball reference, or whatever site you happen to be getting data from, it is possible, and we don't want to deal with that. So you can be pretty certain that NBA has a database on their servers that's driving this information. And sure enough, if we look at the player, let's see, that is not what I wanted to zoom in on. So sure enough, if we look at the player right here, you'll notice, let's see if we can make that a little bigger. Yeah. You'll notice that there's an ID number here. Okay? So this is a reference to stats/player/201142. That is going to be Kevin Durant's ID number for this table. And we can click on that, and it'll basically just take us to Kevin Durant's stats page, because that's where this information is coming from, is for his record in their database. No big deal. But that's his reference number for their system. So we want to pull that number out. So what we're going to do is we're going to create a second list, or a third list, I guess, because we have our header list, we have our player stats list, or list of lists for the player stats, one for each player. And now we're going to pull out a player ID list. And to do that, we are going to loop over And we're going to pull out the row I, the ith row, because remember we have a rows variable here that finds all of the rows in the table. They're hosted as that object. The rows object has them all. So for I in range 1 to length rows, so we're going from the first row all the way down to the last row, we're going to pull out our rows. This is just basically saying what row we're on. Rows, this number, because that rows object is a list. We're going to look for dot A, and just like we did up here with td.getText, A for A in header list, h.text.strip for H in headers, A is going to be the anchor, is what they call it. So we're looking for the anchor in that row, and it happens to be the only one, thankfully. If not, we'd have to find all of them and then get whichever one we wanted. And we can see we have this anchor here. It's going to be the link, and we have some slashes. We have more than what we need. So what we're going to do is we're going to split it, since it's a string, or we're converting it to a string at least. We're turning it into a string. We're splitting it by the slash, and we want the third option, because we're going to have 0, 1, 2, 3. And we're doing that again for every row. And then we're changing it to an integer. And then we're going to do for item in player stats. So now we're looping over this list. So for every list within this list of lists, we're going to be inserting to the 0th position of that list, so the very beginning, player IDs, and we're wanting to pull the same number that we are within the player stats list, right? Because we went every row for the stats, every row for the ID, so the third entry in the ID list is going to be the same as the third list in the player stats list, right? So just so you guys can see what we're doing here, I'm going to go ahead and comment those out and run that. And so you can just see what we have. We have header list 1, if I could type. So that's our headers. Those are the column names, which if we come back here and look, those are the column names. All right, that's all fine. If we look at player stats, we can see it's a list of lists. So each player, each row within our table here is going to come through as a list. So we have Kevin Durrett, Brooklyn, 33, 13, 9, 4, 34, 7. Those are just our numbers here going across. So we pull out all of those for him, and then we move on to number 2, Steph Curry. And we pull out everything for him, move on, new list, Giannis Antetokounmpo, pull out everything for him, so on and so forth, right? Now if we look at player IDs, it's a single list of just those ID numbers, right? And we go all the way down. So what we need to do is we need to take each player's ID number and we need to insert it into their list here in front of the name. So it'll be ID number, name, team, age, games played, wins, losses, so on and so forth, right? So to do that, we're going to loop through and do for item and player stats, item. So we're doing for item and player stats. That's going to, the item is going to be each of these individual player lists, okay? So for each of these player lists, we're going to insert into the 0th position, which is the first one. If we do player stats 0, we're just going to get Kevin Durant. But as you can see, that's one of the items. So basically we're just doing player stats 0, player stats 1, player stats 2. If we take the 0th item of that item, we just have Kevin Durant. So we're inserting into the 0th position, so the very beginning, okay? And let's just do this so we can see. Insert 0, first position, okay? If we do that, then let's look at player stats 0 again. We can see first position is now, so we didn't lose any information, right? We're just adding that in and sliding Kevin Durant and the rest down. But if we look at player stats 1, we don't have that. We just start with Steph Curry because we only inserted it into the 0th object. So what we want to do is basically, we'll do for player, that's fine. For player in player stats, So for player and player stats, we want to player.insert, because this is each of those individual rows, right? So if we do that, and then look at player stats, first position, because Kevin Durant already had first position, that's why I got put in again. First position, Steph Curry. First position, Giannis. First position, Paul George, right? So it did that for every single item. Okay, we don't want that though. So we're gonna rerun that so our player list is clean as the freshly fallen snow. So now we're back to Kevin Durant is number 1 in his list. So what we're doing here is we're calling player IDs. And remember how we did the 0th player stat? Well, we're basically doing the same thing. So if we do like player stats dot index here, player stats 0. So A equals player stats 0, Kevin Durant. If we call player stats dot index A, so we want the index of the 8th item, it's going to give us 0 because that's the 0th item in that list. The index is just its position within the list. So if we relook at this now, for item in player stats, so for every individual player and their associated stats, we are representing them as the variable item. We are then inserting into that individual item, into the 0th position, the player ID. Okay, now this is where we bring the index in. We need to insert it into the same position that it is in the player stats, because it's a 1-to-1, right? For every player, we have every player ID going down in the same order. So we need to figure out where in the player stats list of lists we're at. So remember, the item is this, or A, and if we call the index of A, we get 0. We're looking for the index of the item, if, I guess, player within the player stats list, and we want that player ID location within that list. So if we do player ID 0, is it player ID or player IDs? Player IDs. If we do player ID 0, we get 201142, and if we look back at Kevin Durant here, that should be his. I don't know why it keeps doing that. Yep, so 201142. Yep, so that is his player ID. So we got it right. So we want to do that and pull out that item for that list and insert it into the other list all the way across the board. Okay. So let's go ahead and do that. We're going to uncomment these, rerun the whole thing, and then we're going to close our WebDriver there because we don't need it anymore, because once we pull the soup object out of the HTML response, we don't need the WebDriver anymore. So just to check, we have player IDs. Player stats has the player ID inserted for each player. And then we've also inserted into our header list player ID as the first column. So now that we have all of our data that we're looking for, we're going to go ahead and create a stats data frame. We're going to create it from the player stats list. We're going to pass the header list for our columns, and we're going to set our index to player ID. Okay, let's take a look at that. So next up, we have our data frame. We want to create, and if this doesn't look familiar, go check out our database intro video because we go over that. We're defining our database file. For me, I'm just going to call it nbastats.db. We're creating a SQLite connection to that file, and we're creating a cursor object, which we don't really need for this, but we're doing it because it's good practice. Now, a reminder here, when you create the connection, if there is not a database at that location, it will create one. If you're trying to add to a database or update it, you'll do the same thing, but be warned, if it's saying, everything isn't there that you think it is, you probably pointed it to the wrong location. So we're going to go ahead and connect. And we do want to check though, because data type is going to become important here. We're going to check our stats table. And lo and behold, every single thing came through as a string object, which is not good because these are numbers, right? We might want to do calculations on these numbers. We can't have them coming through as a string. So we need the player to come through as a string. We need the team to come through as a string. Everything else should be a number. And we can see here that our index is an integer, which is good because that's a number. So what we need to do is we need to basically change all of these to be numbers. And to do that, we're going to create a columns variable, which is just calls equals stats.columns. That's just going to create a list that is all of the columns in the table, right? And to change that, we're going to slice that list. And we want to start with, we're calling it 2, but really it's the third column because Python starts at 0. So 2, age, if I'm pointing, you can't see, I'm pointing, but I'm going to highlight it too. Number 2 is age. So if we start at number 2, that means we're starting at age, even though it's the third entry in the table. And that's where we want to start. So we're just going to slice and take that section of the data frame, and we're going to apply the function pd.toNumeric, which is going to try and force them all to be numeric numbers rather than string objects. And we're going to say if there's any errors, we're going to coerce or try and force it into a numeric value. Okay, so this is if it came across anything that it thinks shouldn't be a number, we're telling it, we don't care. I said it's a number, make it a number. All right, that's what we're doing with this. So we're going to run that, then we'll check stats info again, and we can see player and team are the two objects. And then we have integers, we have floats, and we have integers and floats. So anything that it can interpret as integers, it's going to, because it takes less memory, because you don't have to worry about precision or anything like that. It's just the number. But if there are decimals, it's going to bring it as a float. So since age, games played, win, losses are all whole numbers in our table, it's going to bring it as an integer. If we wanted to, we could force them all to be floats, but we don't want that. Alright, so now we have all of our columns, we have all the right data types. It's time to send it to our database. So this is going to be very easy with Pandas because there is a very simple toSQL function we can use. So our stats data frame, right, stats, toSQL, we are naming our database table that we want to create or update. We're calling our connection to the database that we specified, and then we're saying if it exists we want to replace. There's a couple different options you could do here. You could append. If you're doing something like box scores, you'd want if exists appends. So if our table exists already in the database, what do we want it to do? In this case, we want to replace it because this is going to be new data every day, the most up-to-date data. Now I'm passing index equals true here because I want the index to come through. If we did index equals false, then our player IDs wouldn't come through. If you don't set player ID as the index, then you would probably want the index to be false because you don't need just the sequential 1 through 451. That means nothing to us, and if we resort the table, it doesn't matter. We don't like it. Don't care. So we want the index equals true. We want to pass it. And then I have this dtype parameter. And I'm passing this dictionary here. And basically that allows me to specify a specific data type if I need to. Luckily, I converted all of these beforehand, so I don't have to specify every single one of these columns and what data type I want. If you need to, you can here. What I am going to do is specify player ID as the primary key. You could do that even if it's not the index in your data frame. I want to be clear there. You can choose any of your unique values here to be the primary key. I'm going to do player ID for now. We're going to run it. We're going to pull up our DB browser for SQLite. We're going to open our database that we just put in there. And now we can see we have one table, pgen traditional. We have all of our columns here. And it's going to refer to floats as real rather than floats, integer still integer. And you can see we have this little key symbol on our little player ID picture there. That's going to let us know it's the primary key. Additionally, we have player ID integer primary key there. And these, you can see it's specifying the column and the data type based on what it was set in Pandas. Now, you can browse your data. If we want to look, we can see it's all there. We can sort by any of these if we just want to look at it, just like you can in Excel. I know this is a nice graphical user interface, a little bit easier than calling everything in Pandas, especially if you're not terribly fluent in Python. This is an easy way to kind of look at everything you have. You can filter, so I only want to look at Boston players. You can resize your columns. This is a nifty little thing you can explore your data with pretty well, right? And you can update your data here too. Not from here. We can modify table. That allows me to change types here if I want to, which I don't. Browse data. Yeah, we can copy it out if we want. There's all sorts of things we can do here. You can update text numeric. I can apply that, and now it's 0. So you can update it if you need to. Just to show you guys the importance of passing that D type, whatchamacallit, we're going to close our database here, discard the changes. We're going to open file locations, delete our database here. Try again. We did not close our connection, so we can't delete it because it's still open. So let's come back in. Try it again. Deleted. So now, even though player ID is our index, and we're passing index equals true, since we're not specifying player ID to be our integer key, and let's just verify here. If we go to open database, there's no database in that folder anymore because we deleted it. If we send it there now, we closed our connection because I'm a big dummy. Reopen our connection to that database, recreate it, and rerun that command without the player ID integer primary key. Come back to open database, NBA stats. If we go to database structure, look at the table, we no longer have a little key here by player ID, and it just says integer now. It does not say integer primary key. So if we do that again, we are going to close our connection again. We are going to delete our database again. We are going to open our connection again. And we're going to do index equals false. So if we had not set player ID to the index, and it was still just the generic, I guess we don't have a head function with it showing that. But when it was just player ID as a column and then 1, 2, 3, 4, 5, 6, 7 for our index, if we pass index as false, and we come back in here and open it up, now we no longer have player ID. We just start with player because we told it not to bring the index with it. So that's that. One thing that SQLite, it can do, but it doesn't do it well, is foreign keys, which is a shame because that can be a very good data control feature. And we're not going to get in, we'll get into a little more of that discussion once we have multiple tables. But it basically allows you to tie your primary key here to a foreign key in a different table, and it says they have to be matching. So if we tried to put in advanced stats and we had a player there, a player ID that wasn't in our traditional stats, or if we had a separate like player table that's just the player and all of their different keys and IDs for the different data sources, we could have it set so if we try to feed in stats for a player that does not exist in that data set with an ID, then it just can't bring the player in. So that can be good to have. For these purposes, I don't think it's necessary because we know what we're getting. We're getting it from reliable sources. We don't have to create that stuff on our own. So I wouldn't worry too much about it. There are other database softwares you can use. RDBMS, relationship database management software, relational database management software. I forget, it's RDBMS, the acronym. You'll see it if you Google it pretty quickly. But that's going to be it for today. We've scraped the web for a table, we've put it into Pandas, and we've thrown it into our database a couple different ways depending on how you want to do it. that's going to wrap it up for today. I would like to again thank everybody in the Patreon for their continued support. It means a lot to me. It still kind of blows my mind that people are willing to pay with their hard-earned money to come hang out in the Discord with me and ask questions and support what I'm doing here. So yeah, if you're interested in joining, get a little bit more access to me. If you have some questions, run into some hard spots, you're not really sure what to do, and you're having trouble getting it answered in YouTube comments, I'm pretty good about answering. I've been bad lately. I haven't had much time, but generally I respond to them with answers if I have them. But if you want access to me or any of the other good folks in the Discord, a little's $5 a month. Feel free to join. And until next time, I hope you folks have a wonderful week.